Welcome back, everybody. We're on to Unit 3, Week 2. We're going to talk about intrusion detection and intrusion detection systems this week. Last week, I know there were a number of you that said, wait, there's no quiz, there's no discussion. I really wanted you to absorb the unit on access control because the other systems we're going to talk about kind of build off of that type of system. So I hope that you took the time to go ahead and do that. I know some of you took an extra week to do the quiz. I did put the wrong date on that, so but that's been fixed, and going forward the quiz will always be in the week in which the lesson is taught. But I wanted to make sure that you really understood the access control. If you're not clear on the access control stuff, please reach out to me. Be more than happy to do a one-on-one by phone with anybody just to make sure you're good on that. But intrusion detection systems in many ways build off of access control and are working together with it. They're integrated with it in many ways. And so understanding the access control is really important. This week we're going to talk about intrusion detection systems, or IDS. So an intrusion detection system, or IDS, is the official name. But when you're talking to security people in general, you'll just refer to them as the alarm system. Now, why do we come up with intrusion detection system as opposed to just calling it the alarm system? Because it's the building alarm system. Well, think about that. There are an awful lot of alarms that are not intrusion detection. The fire alarm system. You could have an alarm system on a lot of different types of equipment in your office or your warehouse or your manufacturing facility, what have you. The beep that goes off when the microwave is done, heating your popcorn, is a alarm system. But we're talking about intrusion detection, something that tells you that someone has breached your perimeter or gone into an area that they shouldn't have gone into or didn't follow a proper process to get into an area. That type of alarm system. We're going to call them alarm systems for the most part. I'll bounce back and forth, but intrusion detection and alarm systems, security alarm systems, are one and the same. It's just when you're talking to people outside of security, try to use intrusion detection so it clarifies that you're not talking about other alarm systems like fire alarms and building alarms for maintenance purposes. Oftentimes an intrusion detection system is integrated with that access control system we talked about last week, and it runs on the same control panels, and you'll see that in the drawing in a bit. But they can also be standalone. Not everybody has access card readers or facial recognition or high-speed fingerprint or some type of device, right, to read to get you in. It could just be a key, but that building may still need an alarm. Think about the places that you might work. There may not be a card reader on the front door of a store that you work in, but there's likely to be some sort of alarm system so that in the middle of the night, if someone breaks in to steal whatever from the store, the owner would know it and the police can be summoned. So there can be standalone that are separate from an access control. They can be silent, they can be audible, or they can be both. So a silent alarm is just that. The door opens and the person who opened the door doesn't necessarily know that they've set off an alarm. There's no signal to the person there. An audible alarm can be anything from just a beep to tell someone you opened a door you shouldn't have, call security and tell them that, or it could be a loud horn to chase away an actual burglar. A silent alarm has to be monitored to be effective. So think about the old saying, if a tree falls in the forest and no one's around to hear it, does it really make a noise? We really don't know. Same thing is true with silent alarms. If no one's going to monitor a silent alarm, no one's going to acknowledge that something just happened, then that alarm system is worthless. Now, an audible alarm has some limited value, but it's minimally effective. If you're out in the middle of nowhere, right? You're out in a building somewhere between Slippery Rock and Grove City. I've taken that drive, and there's, it's a short drive, but there's a lot of open areas there. If you have a loud horn on a building when someone breaks in, it might scare them away, or they might just knock the horn off the wall because no one else is going to hear it. So they're minimally effective unless they're in an area where it's going to do some good. And we see that now with car alarms. People have car alarms and they go off all the time, and very seldom does someone even look because they've become so built into the landscape. So silent has to be monitored. Audible has a limited purpose. So as I said, there are two main types. There are other types of intrusion detection systems out there, but the two main types that you will run into 99.9% of the time are an integrated system, and it's running as part of your access control. So it's just another input going into that access control panel, the one that the reader went into and the electric strike went into. Remember all those wires? And you just have an alarm that goes in there as well, and I'll show you how that's hooked up. The other is a standalone. It runs on a separate panel that the owner sets when they come in the morning and usually go home at night. And you've seen these. In fact, if you ever had a home alarm system, it's a panel on the wall. It has a numeric code. When you walk in, it beeps at you and you put in your numeric code and hit enter. and it shuts the alarm off. And when you leave, you set the alarm and you go about your business. Those report to a central station. So when you think about a standalone system, just think along the lines of, the ADT system is, it's kind of one of the main dealers of these things. Or a home alarm system, same thing. So integrated runs on access control panel, one we talked about last week. Standalone looks like a home alarm system. So really simply, when you've got an integrated access control and alarm system, there are door position switches, something that tells you when a door is open or closed. We'll talk about reed switches in a second, but they're commonly referred to as contacts on the door, and it tells whether or not the door is open or closed. When it's open and it's not supposed to be opened, it reports back to the control panel. You add an extra board in the panel. And, the panels have these little printed circuit boards. You just add an extra one, a little extra wiring, but it's essentially integrated and it's part of that panel. Okay? And it reports through there, and then it sends a signal back to your host to say, hey, someone just breached the door that you set an alarm on. Go do something. There are other ways to do it. We'll talk about that in a bit, but that's the basics, right? A door position switch opens. It reports back saying this shouldn't be open. Something should have happened. Someone should have used a badge or put in a code or something before they entered the door. This door should never be open during this time frame. Somebody used a crowbar on the door, right, to break the door apart. Even if they use their key, anytime the door opens up and you want it to cause an alarm, you've got it set to do so, it's going to report back through that control panel and then to the host to tell you to do something. So how does the system know whether the door is opened or closed? Well, it has something normally called a reed switch on the door, and there are other ways to do it, but the reed switch is pretty common, and then when you see a picture of them in a second, you'll say, oh, I know what those are, right? They're a type of switch. They report open or closed position using magnets or plungers or something that separates and causes the system to say, hey, half of me is not touching the other half, right? They're usually magnets that are balanced inside so that you can't tamper with them. They're going to be supervised, and we'll go over supervision, but they can be surface or recess mounted. And let's take a look at where they go in the system, and then I'll show you some pictures of some reed switches, and you'll get an idea of what they are and how they work. So here's our picture that we used last week, and right here, I know that this is kind of a bad picture because it almost looked like a maglock. They're so darn big. These things are really not very big at all. They're only usually about 3 inches, maybe 2 or 3 inches. But they're alarm contacts. And essentially, when the door opens up, these two things, this is a standalone magnet. It's, in this case, screwed to the face of the door. This one is up above it on the door frame. And when these two things separate, it says, we're separated, goes up here and says, you have an alarm. And it says, yep, you do. And it goes up here to the host and says, you have an alarm. Now, one of the things that's kind of unique is that if you use the reader to get in, the reader signal and the door separation are coming in just about the same time. First you use the reader, and then you open the door. When you use the reader, it goes up and it says, a reader is being used to open the door, and Brian is allowed in here. So when this alarm comes in, ignore it and don't report it to the host. It's called shunting the alarm. So when you use a legal entry to come into a door, the alarm won't come in. Now, if I don't use my card on this card access reader, instead I use a crowbar to open the door, this signal goes up here and says, hey, these two sensors just separated. The alarm contacts, the door sensors, the reed switches just separated. And there is no valid entry or exit using a REX device we talked about. So send in the alarm to the host and tell them something's wrong at that door. That's basically it. It's an open-close kind of switch. When it opens, it sends in an alarm. If something legal happened to tell it it's okay, it will automatically not send that alarm to the host, because then you don't need to send a guard or go run over and see who just broke in the building. It will tell you that somebody legally went in, and that all happens in here. It makes that decision and doesn't send you anything. So here are two surface-mounted reed switches, right? Contacts, as they're generally called in the industry, alarm contacts, but they are reed switches. And the reason they're that are, in here are little metal reeds. They look like a little flap of metal, one here and one there. And when the door is together and close enough, these two things are pulling on each other. And when they separate, this one flops up, this one flops down, and this one right here is the one that reports, and it says, hey, my magnet reed is not down here where it's supposed to be, because it was being pulled by this one. Instead, it just popped up, which means there is no magnet holding it. When I said they're balanced, just a gee whiz for you if you want a little extra information. Oftentimes people say, well, if they're just magnets, I could shove a magnet between the two of them, keep this one pulled down, and open the door and no alarm would come in. Not true. They're balanced. The magnet in this one is the exact same strength as up here, so that they stay in a kind of a same position, right? The magnet, the reed is pulled down this way and pulled down this way. If you put a stronger magnet in, it's going to pull it too far down and it's going to cause an alarm. And if you don't have a strong enough magnet, it's going to flop up. They're completely balanced and put up and set that way so that the two reeds will separate inside based on the magnets being pulled apart, one on the door and one on the frame, and that's what causes the alarm. Now, the kind of reed switches I showed you before, the kind of alarm contacts, you'll see those all over. If you look around campus, just about any door that you might even think would be alarmed will have that type of contact. They're very easy to install. They're extremely cheap. I mean, I can buy a set of contacts for under $5 if I shop around. And just about any installer can put them in. Now, these are called recessed contacts, and the reason they're called recessed is that this one goes in the top of the door itself. Now, think about the top of the door. When you open a door, reach to the very top of the door, and there's that flat surface, the thickness of the door. One of these goes in the door, this magnet, and the other one goes in the frame. And I'll show you how those are cut. So very simply, you take a drill, and you drill a hole straight down in, and you put that one magnet, the one without the wiring, straight down in, and you tap it in. And then over here in the door frame, you'd line up on this edge over here, and you'd have your other contact with the wiring going up. So they're not surface mount. They have a lot less chance of being damaged if you're bringing stuff in and out of the door. They're much, much harder to tamper with because you can't get to them. And next time you go to a door and you think it's something that probably should be alarmed, and you'll see this on a lot of like malls and things like that, they don't have those surface mount ones, the reed switch ones that we showed before, but they'll have this type. And when you open the door, just reach up to the top of the door, feel, and you'll feel this little plastic magnet piece right here. It's a plastic piece. It feels like a little plastic dot, and there'll be one on the top of the door as well. It just looks like a little plug. The door's been pre-cut for those, and they actually are alarm contacts. Same principle for big overhead doors like the ones on our project on the warehouse. You would mount this to the overhead door, and this would be mounted directly and screwed right into the concrete floor normally. And when the door goes up, this magnet separates from this magnet, and it says, hey, we've got an alarm, the door is open. And when the door comes back down, this is on the base of the door, it comes and sets on top of this one, and it says the door is now secure. You notice that it has armored cable, and these things are heavy duty. They're meant to be rolled over, this one right here, rolled over by a forklift. And that's why it's heavy duty. And this part would never really be touched because it's going up with the door or coming down again, so it's unlikely to be damaged, although it does have a big metal frame. So these are just the same type of reed switches as this type, but they're just heavy duty, and instead of going on the door frame and on the door itself that way, they go on a overhead door on the bottom. This gets bolted on right here through these little holes, and this bolted to the floor. You'll need those. You'll need the knowledge of those surface-mounted contacts for overhead doors for our project. One more type that's less used for doors and more for drawers and things like that, smaller applications, are plunger-type contacts. And you basically have your wiring going back, through to your panel, right? You're connecting your wires on these two screws right here, a twisted pair of wires. And this bolts on the edge, and when the door or drawer is closed, this plunger is in. And when you open it, it's on a spring and it just pops out. And when it pops out, it separates magnets in here, same type of setup. But it's just a plunger. It's a single-sided device. You don't have one on the door and one on the frame. You can just use it on the frame. The springs tend to wear out in these, so you don't see plunger contacts used on anything that's done on a door that's really heavily used. You wouldn't see this on a main entry door anywhere. These things can get damaged pretty easily. But on things like a drawer or a cabinet where you're storing things, where you're only opening it maybe 5-10 times a day, these are pretty good. Not a bad idea. And sometimes the best application to use. So the great thing about all those types of door contacts, reed switches, plungers, all those types of things is you use the same sensors on the door for your standalone system. Now, I think we've all seen this type of panel somewhere on a wall. If you haven't, Next time you're in a doctor's office or a small retail, you'll see these things on the wall all over the place. They're the alarm system, and when the owner comes in the morning, they have a code they put in. They put in the wrong code, they get a phone call from the alarm company saying, "Are you okay?" If they don't set it, it sends an alarm in saying somebody broke in the building, and depending on what arrangements the owner has made, either they'll get a phone call or the police may be summoned. You'll notice this one says DMP. That's what those initials are on there. And DMP is a major manufacturer of these types of panels. Also, Bosch is a major manufacturer. You'll only find really in an industrial setting those two brands, DMP and Bosch, and you'll hear security people talk about put in a DMP or put in a Bosch panel. And so I call that to your attention only because you'll hear me say that too. It's a standalone alarm system control panel, is what it is. But we'll mention those two. It's almost like saying pass me a tissue or pass me a Kleenex, right? Kleenex is a brand of tissue. DMP and Bosch are major brands of these panels, and security professionals tend to just refer to them as DMP panels or Bosch panels. So how do these standalone system work? Well, you need that panel, right? The DMP panel, Bosch panel, alarm control panel if you so choose. But when you say alarm control panel, sometimes you're talking about the one that's integrated, the one we talked about last week, right? The control panel, or this type. So try to get used to saying DMP panel or Bosch panel only because it's just so commonly used. They use the same type of contacts on the door, but instead of the wiring going back to your access control panel, all the wires go back to this panel, the one on the wall, the one I showed you, this DMP panel here in this picture. It happens to be a DMP. So all the wires go back there. Now, when the panel is armed, when it's turned on, and the contacts are activated, someone opens the door, the central station, whatever service you got your alarm system from, gets the call, and they have a set process with the owner. It might be anytime you get an alarm, like a jewelry store would say, if an alarm comes in from our panel, send the police. If it's a lower end retail, they may say call the owner and they'll go take a look at it, or an office setting where it's normally not subject to being robbed, right? A law office. A doctor's office, if they store samples, might want to have a police presence. The police will charge, by the way, for responses to alarms after a certain number usually, and it's not cheap. Usually it's about $500 for them to come out and check. So you don't want these things to malfunction. But when it's armed, it just sends in the signal to that panel. Now they can be zoned, so you could put in different panels in your building in different areas so that if, like with the doctor's office, you come in the morning and you turn off the panel for the main alarm system, it now turns that off, but it keeps the one on the pharmacy that you have where you're storing perhaps OxyContin, which is a very popular thing to steal from doctor's offices, right? And you could go in and then say, I want to go to zone 2, which is the Oxy Vault, and I want to turn that one off when you want to go in to do an inventory or dispense medicines, right? So they can be zoned, but normally they're set up with just a perimeter. They're used really almost primarily for perimeter protection just because it's easier that way. Now, the one thing you have to think about is, remember that panel, it's got numbers on it. It's a code. And you have any number of codes you can ask for, give everybody in the building their own code. But most of the time, you don't want to do that because if you have 50 people working in a building, anytime someone leaves, you have to have someone take that code out so that it no longer works. And you'll find, this has been my experience, is that when someone leaves and you take their code out, you find it still gets used at least once or twice because someone has shared their code with someone else who doesn't have a code of their own so that they can get in and out of an area because that's how people are. So the big thing is they're subject to code sharing, and you've got to be very careful about that. So a big question is, can you mix these systems? And the answer is yes. And let's take a quick look at the picture, and then we'll come back to this slide. And the picture shows us here that we have alarm contacts on the door, and they're going back to the panel. And if you run your badge, the alarm won't come in because it's telling the panel, don't report it. But if it does come in, it goes up and it goes through a DMP or Bosch panel before it gets to the host. So now it's going to report to the host, but it's also going to report to the panel. And why would you do that? Well, there's a very good reason. The DMP panel can be wired so that it reports directly to the police. So after hours, if you have a guard who's sitting here in your building and an alarm comes in from this door, it goes up and it goes to the DMP panel and it goes to the police, and it goes to the guard. The reason that you would do this is you don't want the guard to be the guy who opened the door and is robbing you blind. Right? 2 guards in a building, if you have a lot of valuables, in my case, we have controlled drugs. At any particular time, I could have $1 billion worth of controlled drug in a vault behind this door. Right? Trying to store them all in one place, but you get the picture, right? Could be some very valuable stuff. This guard and the guard walking around in the building could conspire to open the door with whatever means necessary, right? The alarm would come into this guy. He ignores it. They empty the vault. They put it in a truck, and off to Mexico they go. In this scenario, the alarm goes in from that very high priority door, and it goes up here, and there's an alarm, and it's going to this guy, but it's also being intercepted here and going directly to the police. Now the police will come to the building to make sure they're not loading up a truck full of your valuables. So they can be mixed. It's a little tough to understand, but you can have a standalone system with just DMP. The doors, instead of going to an access control panel, these contacts just go directly to DMP and to an alarm monitoring station of the police. Or you could have it go to your panel and no DMP and around to the host, and you monitor your own alarms. Or you can mix the two and have the alarms go to 2 separate places, so there's a checks and balances when you have an alarm on a very important resource. So when we mix the alarms, let's get back to this slide, they can be effective for buildings where there's no one sitting at the host, right? So you may have a guard after hours, but not during the day, and you still want the alarms to go somewhere, or vice versa. You have a guard during the day who's your receptionist, and there's nobody there at night. So at night, they're going to go through a DMP panel and report to somebody. During the day, those alarms would just go to the host where the guard's sitting, and he gets up from his post and goes and checks the door. So you can mix them that way. It can be placed between the access control panel and the host, and it sends signals to both the host and to the third-party monitoring company. So you have 2 people now getting that alarm, one inside the building and one outside. And it's often used as a checks and balances to make sure the person inside the building that you trust is also being checked by somebody that he doesn't know from the outside. And what you have to be careful of is that the alarm company just doesn't call the guard and say, hey, are you okay? Your alarm just went off. Because if he's robbing you blind, he's going to say yes. You want to make sure you have a protocol that says if an alarm is received from the DMP panel at the alarm company, send the police and tell the police there's a guard in the building and this is how you contact the guard. And then they can check to make sure that everything is secure and the guard isn't the one who is potentially robbing you. So we talked about supervision. What is supervision when it comes to an intrusion detection system? And supervision tells you when a line is cut. And you notice that no matter where your alarm contact's wiring is going to, it's going to your own internal access control panel, to that board, or if it's going to the DMP or Bosch panel, to that board, no matter where it goes, there are physical wires involved. And supervision will tell you if someone cuts that wire. Now, when we looked at the alarm contacts on the reed switches, and I'll go back to that. If you look here on the surface mount, there's 2 wires coming out, and a lot of times those wires are bare and exposed, right? You got a little bit of space, and then they go into, into a door frame or something like that. But there's usually a little bit of exposed wire here. So if I cut these wires, now no signal is going to happen here, right? There's absolutely no signal. That's where supervision comes in. Okay, supervision basically gives you the ability to say, I have a problem. What you do is on those wires, you put a resistor on one of those wires. And it's added in, and it basically says, it allows the system to tell you, to give you one last cry for help. If I cut the wires and I have a supervised system, it's going to send in a signal that said, my line has been cut. It can't tell you anything more after that because the line has been cut. But it holds the information. It's like a buffer. Think about buffering when you have a song, right? When you're listening to a song on your cell phone and you lose your cell phone signal, you'll still listen to the song because the song is buffered in there. When it tries to switch to the next song, that's when you're going to have trouble because you don't have a connection to get it downloaded, right? It's essentially doing the same thing. It's buffering one signal in there that says, I have a problem. If you don't have that there and somebody cuts the line, you just won't know it. It's just going to go dead, and there's nothing to tell you that there is a problem. You should always supervise alarm lines. Installers have to be told to do it, though, because adding that resistor is an extra bit of work. It's an extra bit of cost. Okay, we're talking about probably 10 minutes worth of work and probably $10 worth of cost. But an installer in a hurry is not going to supervise the lines unless you tell them to do that. Okay, unsupervised alarms are a boom, boom. False sense of security, because you think that you have your building alarmed, but if somebody cuts your wires. So, when you hear about someone broke into someplace, how did they get in? Well, they cut the wires to the alarm system. If the system were supervised, someone would have been told with that last bit of energy in that resistor would have sent in, I have a problem. And so always supervised alarm points, very important for you to understand, always spec supervised alarm points. So other types of contacts or sensors that you could hook to an alarm system, well, there's just about anything, really. Infrared motion detectors, right? You could put a motion detector in the corner of the room, and if something moves in that room, it's going to tell you. It's going to send in the alarm. Anything that's a switch, a glass break sensor, a dual technology one, by the way, which reacts to both sound and vibration. They make them that way so that if you bang on the glass, it doesn't send an alarm. Or if someone drops a glass bottle in the room, it doesn't send an alarm. It has to have the vibration from the glass and the sound at the same time on the piece of glass that the contact is on. But anything, a heat detector. If you want to get an alarm because there's heat in the room, which means there could be a person that's hiding in that room. Laser sensors, the Mission Impossible, Tom Cruise climbing through the beams, that type of thing, right? Microwave sensors, big microwave sensors on the outside of prisons. They look like a bass drum, like they play in the marching band, and they face each other, and those are microwaves going back and forth, and they'll go 100 yards in some cases, and when someone breaks that beam. There are ground drop sensors around nuclear storage areas. When you walk up to the fence, it senses the vibration of you walking up to the fence in the ground. That type of contact. Gunshot detection is a great one now that people are putting in. When the sound of a gunshot is detected, it sends an alarm saying you have a gunshot, and which detector picked it up first will tell you the general area of where it's coming from. Anything that changes a status can be an alarm contact. Think about when you use programs with the if this then that. If this happens, then I want an alarm. As long as you have a sensor that can pick it up. If someone turns on the lights in the room, then I want an alarm. If the automatic sensor on the lights comes on, I want an alarm to come in to tell me that somebody went in the room. So you don't necessarily need to put another motion sensor in. You could wire the contacts essentially to be the switch that turns the lights on automatically when you walk in a room, those sensors that pick you up when you come in. And then you could have it send in another alarm when it goes off so that you know that somebody's been out of the room for X amount of time. A two-man rule detection is something you'd use in a high priority resource where you want to make sure you have two people in the room at all times, right? If you're in a counting room in a casino, if you're in a drug dispensing room in a pharmacy, you may have a rule and or a law, that says two people must be in this room at all times. That's to make sure that one person doesn't go in and do something out of practice, out of policy, or steal something. You could set up a heat sensor to show two people are present in the room because it's picking up the heat off two bodies. And unless you get two signals, send an alarm saying we're only getting one. Go send someone to find out why someone's in that room by themselves. So just think about if this, then that. Anytime you can have a situation trigger something, you can get a sensor to record that and send it to your alarm system so you know it's happening. The reed switches, the door sensors, very common for intrusion detection, but also any of these other types of sensors, and there are lots of them, and you can really use just about any trigger to pick up intrusion. And so don't always think about plungers or reed switches or those types of things. Anything that you use that turns something on and off, any switch, can be used also to trigger an alarm. So that's the down and dirty of the electronics of alarm systems, right? Two different types. May go to a commercial type panel like a DMP or Bosch. May go to your own access control internally. You can mix the two if you want so that you have signals going to two different places. There are tons of different contacts you can use. There are some common ones like the reed switches, the balanced contacts, those types of things. But anything that gives you that if this, then that scenario. If this, then I want an alarm. If there's a trigger, you can get it to alarm. But let's talk about false and nuisance alarms. It's very common to hear someone go to an alarm response, let's consider a security guard goes to alarm response. You get an alarm from a room. You're not supposed to have an alarm there. Nobody's supposed to be in there. The dispatcher sends the guard, and they get back and they say it was a false alarm. It was just Jim in the room. He was in there working on something. He's not supposed to be in there at this time of day, and I sent him away. That is not a false alarm. That is a nuisance alarm. And there's a big difference between the two, and you really need to understand them because one requires a maintenance fix and the other one may not. So a false alarm is caused by a system fault. Okay, a loose wire, broken contact, some other malfunction in the system. The system's not working properly and you are getting alarms. That's a false alarm. But a nuisance alarm is caused when the system is actually doing what it's supposed to do, but somebody or something is triggering it and it wasn't anticipated that they should do that. So if a repairman disconnects a wire on your system, that's not a false alarm, that's a nuisance alarm. False alarm would be if the wire broke by itself and the system went down. It's not working. Somebody did something to make that alarm not work or alarm come in. So very common, you'll find that during air conditioning season, the air conditioning vents come on from the ceiling and they will blow papers around on a bulletin board. People put papers on bulletin board. They put one thumbtack in the top of it instead of the bottom. So the bottom flops around, and if you have a motion sensor in the hallway, it's going to pick up that paper bouncing around. Set very, those things are set very tight. And when you get things blowing around, it's going to pick that up. That's not a false alarm. The system did what it said it was going to do. I'm going to pick up motion. If I pick up motion, I'm going to tell you about it. It's a nuisance alarm. Someone did something that triggered that alarm that needs to be changed. A lawnmower running outside a window if it has glass break sensors, right? That's not a false alarm. The system picked it up. It's a nuisance alarm. The person should be trained that they either need to tell you when they're going to do that, or they shouldn't get so close to the glass, and they should use a weed whip near the front of the building instead of getting so close. A false alarm requires a technician to fix. If you're getting false alarms, it means your system is broken. If you're getting nuisance alarms, it means that you may need to adjust the system a little bit to make it a little less sensitive, but normally it's a training thing. You need to train people on what not to do. You need to go to that room where people are putting things up on the bulletin board and move the bulletin board. Or tell people, please use 2 thumbtacks to keep papers from blowing and setting off motion sensors, because the motion sensors are usually right there and people know they're there. It's a training thing. So know the difference between a false and a nuisance alarm and start to use those terms when you talk to people, when you join the security management fraternity, if you will. Please, when someone sets off an alarm, that is never a false alarm. The system did what it said it was going to do. It just did it when it probably shouldn't have, or you didn't anticipate that's what you were really looking for. Know the difference between false and nuisance alarms. Really important, and you will definitely see that one again. So common points of failure with alarm systems. Renovations. Certainly, whenever someone does something to a door, and doors are the number one thing that are alarmed, right? They're the portals. They're the way people get in and out of things. They're the way people normally break in and out of things. Doors and windows, primarily. When people do renovations, that's when you're going to get failures. They're going to take the contacts down. They're going to fix something. They're not going to put them up properly. The other common point of failure is when monitoring people set alarms to ignore. If an alarm comes in, either false or a nuisance, too many times, the janitor comes in every day at 7 p.m., and instead of using his badge to get in the room, somebody put the wrong lock set on there, and the janitor uses his master key. When he opens the door, it causes an alarm. And after a while, the alarm monitoring person gets tired of hearing that, and they say, oh, that's just that janitor that we didn't train right, and they set the alarm to ignore at 7 p.m. Now, I will tell you a horror story of alarm systems and ignoring. Bristol-Myers Squibb in Connecticut had a very large warehouse, and there was a bad electrical storm one night, a thunder and lightning storm, really bad, high winds, and alarms were kind of going off all over town, right? That's the type of nuisance alarms, right? It's picking up on something. It's picking up on things bouncing off the glass. It's picking up on doors rattling too hard because of the winds, fluctuations in power. These were nuisance alarms. They weren't really false. But the alarms kept going off at a Bristol-Myers Squibb warehouse, and the police went out 3 times, circled the place, said, look, it's a storm. They're going off all over town. And the alarm monitoring company finally said okay and set it to ignore. What they didn't know was the alarms were not being caused necessarily by the storm. There was a group of people there that were tugging and pulling on doors, purposely setting off those alarms so it looked like there was a problem with the system. Once they did it the final time and the police didn't show, they knew that the alarm monitoring company was ignoring those alarms. They went into the building, stole $150 million worth of pharmaceuticals using Bristol Myers' own forklifts to load up their truck. So setting things to ignore is a big point of failure on alarm systems, and they're normally associated with nuisance alarms. Again, if you train people to use them properly, then you can keep them running all the time and you won't have that issue. But one of the biggest things that will come back to haunt you is if you have installed alarm systems and you don't test them on a regular basis. You need to have a set and structured protocol for testing those alarms. Okay? If an alarm doesn't work, after you have a break-in and no alarm came in, and someone finds out that you did not test that alarm for the last 6 months, your insurance is probably not going to pay. You had a way to detect this and you didn't do it. And you're probably going to lose your job. That is just a done deal. When you say you have a building that is alarmed, you need to make sure it's alarmed. And the only way to do that is to show that on a regular basis you are rigorously testing the alarm system. You verify the test in the system history. So you go to a door and it's set to alarm, and you pull the door open, right? Without, you use a key, you use something else. You don't use your badge to open it if it's badge edge door, or you just use a key and open it. If it's an alarmed emergency exit, you crash it open, and the system will record that an alarm came in at a certain time. You keep that alarm test and keep those records. I would suggest on a normal building, if you have a normal intrusion detection system, somewhat priority resources, very hard to tell. I mean, there are some buildings that test them on a constant basis. Someone's always testing alarms. They're done daily. I would say that never less than monthly would you test alarm systems on any building where you've taken the time and energy and money to install an alarm system. And you can also hire the installer who put the alarm system in to conduct the test. The Department of Homeland Security does that very frequently with airports. The alarm systems have been put in, and DHS has told the airport authorities that only a licensed installer will do the alarm testing. And so they go around every week on most airports, and they'll kick open those doors going out to the aircraft and to other priority areas to make sure the alarm comes in, and they keep records on it. So you can consider hiring an installer to do that if you have the budget to do it. If not, your guards can do it. If not, if you're a one-man show, then one-woman show, you're going to go out there and do it weekly or every 2 weeks or monthly. However often you say you're going to do it, you do it, and you keep records, because you don't want the alarms not to work when they're supposed to and have to explain that after the fact. So there was a lot of information there and a lot of technical information, and you're probably saying, oh my gosh, how am I going to remember all this? Well, there's a few key takeaways. Got 2 slides of key takeaways. If you understand these things, you're going to be in pretty good shape, right? The other stuff is good to know, but if you understand there are generally 2 main types of alarm systems in buildings, integrated and standalone. The integrated system is generally self-monitored. It goes back to your host. And a standalone system generally goes to an outside agency, although you know that you can mix them, right? Both run on some type of sensor or contact. Okay, doors are normally reed switches of some type, either the recessed type, the plunger type, or the surface-mounted type that I showed the pictures of. That's just a standard contact. It's very easy to install, and they're so simple that they tend not to break or break down on you. So that's what normally people use on doors. The standalone panel is also known as a DMP or Bosch panel. You'll hear me say that because I'm not going to get out of a 50-year habit of saying that, or like 35-year habit of saying that. That's what people in the industry will call them. They are an alarm control panel, but security professionals will refer to them by the brand normally. You need to understand what supervision is and why it's important. Remember, it's a resistor in the line that sends in that last cry for help to tell you if somebody cuts the lines. If you don't have supervision in place, you won't know when a line's cut, and your alarm system is then worthless. So supervision has to be in place, extremely important, and you need to tell the installer to do it because they won't do it on their own. A couple more key takeaways. Have a general idea of what can be used as a sensor. That if this, then that is your thought process. I want something to trigger an event. I want something to trigger an alarm to come in to either the police or to my own security or to go to a cell phone even. I mean, you can have them report just about anywhere, right? The host can then send out emails to you and tell you an alarm went off, any number of ways. But what do you want to trigger that alarm? So if this happens, then I want an alarm. And so that if this will give you a general idea of what type of sensor or what trigger you want to come in to send in the alarm. Know the difference between false and nuisance alarms. How do you address each as a security manager? You know that false alarms are a system malfunction, and therefore you need a technician to work on that to fix that malfunction. A nuisance alarm is normally a failure of a person to notify you or to use the system properly, and that is normally a training thing. But know the difference between false and nuisance and use that terminology. It's a false alarm or it's a nuisance alarm. Make sure your guards, when you get into a security management position, if you have guards, use that same terminology so that you know whether you need to send a technician or whether you need to go retrain someone. And then, really important, remember, alarms that don't work are a big problem. Not just that you're going to miss that event, but it is going to call into question the validity of your entire program. You have said that you are protecting us by having an alarm system in place, and that alarm system, you can't prove that it worked any time in the last year because you didn't test it and keep testing records. That's a really bad thing. Test the alarms, keep some records. Okay, that's intrusion detection in a nutshell. And we will talk more about it when we talk about integration, but I think you know enough now about intrusion detection to know that you need door sensors of some kind, contacts, window sensors, some kind of a sensor. And if this, then send an alarm. You know that they go through different pathways, and you know that they'll either go to the police or to the host, and you have to have a response. You know they need to be tested. You know the difference between false and nuisance. I think you're good. Let's talk a little bit about our projects, and I've been sending out little bits and pieces. What I think you should start to do this week, and you don't need to start to do it because you're going to have midterm week to do it, but look, some of you want to get ahead, and I would start to do this because I think that midterm and spring break kind of go into each other, and I have midterm week as simply midterm, nothing else, right? I'm going to send out a lecture midterm week to talk about this project again to make sure that everybody delivers on what they need to deliver on for the midterm. I'm just not going to send out a list of here's the things you need to do for the midterm. There'll be an actual lecture on how to do it. But you can get started by filling out that door hardware schedule. In the scope document, I sent out two things, a diagram and a scope document. In the scope document, you'll see there's a section on door hardware and lock sets. And in the red section, you're going to tell me what type of lock set you're going to use on every door, and you're going to tell me why in like one sentence. I'm going to use a storeroom lock on the men's restroom because I think it's the right thing to do because it remains locked all the time. I mean, it's silly. You wouldn't do that, but that's what I'm looking for. Why you use that lock set, what feature of that lock set is important to use it on that particular room. Fill out that section. Nothing needs to go on the drawing. You're just filling out the section. Now, on the drawing, start to consider what doors you might want access control on, electronic access control, right? What type of credential might you use? How many panels might you need to do that? Okay, so access control is a very expensive thing. So it'd be really easy to say, well, I'm just going to put, facial recognition card readers on every door. That'd be cool. And I have a high security building. Yeah, you'd have a very expensive building too. And trust me, later on in the term, I'm going to start to give you some budget cuts on this project. And you're going to need to trim things down once you find out how expensive your project might be, because you're going to need to put a price on it at some point. And I'll give you those prices after you spec it out, which is pretty common. So think about access control. Do you need it on the outside of the building? Does every door on the outside of the building need to have a card reader? And I say that because the more entry points you have, the more exit points you have, the more things can go out those doors, right? So some doors, maybe you want to filter everybody through one or two doors and have any other outside doors just be emergency exits and put alarms on them. But start to think about how many card readers or readers of some type. I use card reader generically. It could be a cell phone reader, could be facial rec, could be fingerprint, could be anything. How many doors you want to put readers on. And then for every two doors, you'll need a control panel. Luckily, our warehouse is small enough. You don't have to worry about the size of the runs of the cable or anything like that. For every two doors, you need one panel. Then start thinking about where you might put alarm sensors. What rooms or doors on the outside might require alarm sensors of some kind. Consider what type of sensor you'd use. Consider who might monitor it, right? I'll give you a hint. The file room in there, do you really want that signal going to the police? Frankly, if you have sensors on the outside and someone breaks in, maybe then you want it to go to the police during non-normal business hours when nobody's supposed to be there. But why would you need to have the file room go to the police? You just need to know if somebody breaches it potentially. But think about where you'd put alarm sensors, and then who's going to monitor it. And if you're going to have it monitored other than the host, then you're talking about either a mixed system or a standalone system. And I want you to tell me, based on what you heard this week, what you would do, what type of system you would put in. Consider those things. You don't need to do anything with it, but maybe you might want to do a few things. Here's a couple of suggestions. Here's how I'd approach the subject. You can do it any way you want. Use the scope document framework that I sent to list your doors and the lock types, and then add a line telling me why you think this is the right lock set to use. Don't go into a full paragraph, just a line or so. Tell me why it's the right one. I think everybody could do that probably in about 15 minutes. Take the diagram. Use colored pencils. I had some sent into to campus if you've grabbed some of those. If not, the bookstore or Walmart has them, right? Colored pencils are better than using highlighters because you can usually erase them. Use colored pencils on the drawing to show where you'd put access control. Use one color to use for readers of some kind, right? Use another color for your panels. Where would you put the panels? You just want them closest to where your readers are, and you're going to need one panel for every 2 readers that you put on doors, right? Use another color to show me where you put alarm sensors. So you just put a little mark over top of the door, next to the door, that I'm going to put an alarm sensor here, okay? You can write in the document, in the scope document, what type of sensor you want to use, or just keep a note of it for now. But I just want you to use a color to tell me where you'd put alarms, where you'd put readers, where panels might go, and where alarm sensors might go, and use 3 different colors for that. And then do a key somewhere to tell me what colors mean what things, right? Because everybody's going to use different colors, because I can tell you use blue for reader and green for contact and red eventually for cameras, but it doesn't matter. As long as you have a key on there, I can tell. And I'll probably be able to tell anyway, but it would help me an awful lot if you would just put a key as to what colors mean. So, go into the scope document, list out the doors and what lock sets you want on those and why, and then use colored pencils on the drawing and put in your access control readers of any kind that you might want to use, if you want to use them, in one color. Put your panels, one panel per 2 readers, in another color, somewhere on the wall, right? Anywhere where you think it might go. And that's pretty easy because you can put them just about anywhere. You just don't want them in the middle of an operating floor somewhere where they might get banged around. But put them someplace where they won't get banged around. Then use a 3rd color to tell me where you would put alarm contacts on doors, and start to understand what type of door contacts or sensors you might want to use. I will tell you that door contacts, I keep saying that, synonymous with sensors because they are the most common one. A motion sensor might be good in a big area, like maybe a warehouse, might be. But normally on a door, you'd use door contacts. And on windows, you'd use window contacts. We are assuming, for the sake of argument, that our warehouse is a block building and does not have windows to the outside, with the exception of the ones that are in the offices. Don't worry too much about the windows. I'll give you a kind of a pass on that. But that's really what you need to do, and then just make a key of the different colors. I think that's pretty self-explanatory, but for some, that might just open up a question mark. Don't be afraid to just reach out. Let's get on the phone, talk it through, and get these things start prepared, because the midterm is going to be, a good portion of it's going to be you turning in that half-done scope document, because we're not going to get to the camera part before midterm, right? And other things that we want to put in that document. And a half-done drawing. With these things on there, it's going to be a big portion of your midterm. So let's start working on that part now, because the other part of the midterm is a quiz, essentially, 20-question quiz. And we can start working on this first part to get it done and out of the way before we get to the second part, which will be released in midterm week. So this week I'll post an example of a drawing, not the same drawing of our warehouse, but a different one, to show you kind of what I mean. And then plugging in the words in the document where there's red text. I made the places where you'll need to put your own words in red. Very long scope document, very few red sections. You're really just going to add a little bit. A lot of it's called boilerplate stuff that's normally in a scope document that just goes in there. So I'll post an example of that this week, so don't panic. This week you have some reading in the text, pages 109 to 121. They use a little bit different terminology than I might use. There's just so many different ways to describe. Just think of them in terms of sensors. They'll talk about contacts and reed switches and different types of infrared, passive infrared, active infrared, all that sort of stuff. Just think of them as sensors, something that does this. And if this, then that. That if this, the thing that triggers, right, the sensor. Just try to concentrate on knowing that you've got something that triggers something, right? Get used to the differences in terminology because that's just the way it is in industry, okay? You got this lecture. Hopefully it was not too confusing for you. And we have a quiz that is due Sunday at 11:59 p.m. I often leave the quiz open longer than the deadline, which is what I did on the last one, because there are some people who have a valid excuse as to why they can't take the quiz in a certain week. A medical reason or some other reason that they've already discussed with me, and so I don't normally close it out. However, the due dates for the quiz are always going to be here in the lecture, and the due date for the quiz this week is Sunday by 11:59. Even if it says that the quiz is open until December 31st, the quiz is due Sunday at 11:59 this week, and anybody who turns it in after that, unfortunately, you won't get a grade for that quiz. So with that, start to work on the midterm stuff. Get your reading done if you haven't done it already. Hopefully you have. And don't forget to do the quiz by Sunday at 11:59 p.m. With that, have a great week, everybody. And if you have any questions, please reach out.